probably we should get started. Welcome everybody. This is Andy Nash, Director of the New England Literacy Resource Center, and I'm really happy you could join us today. As you heard from Ben's messages he's been sending you, this webinar is being recorded, and you'll get a link to it if you want to review it again or share it with colleagues. It will also be posted on the NLRC website. So as you can see, this webinar has been developed by a team of people. As you see at the bottom of the slide, the NLRC math team. These are 5 professional developers around New England, and we have one from New York, who have gotten together to develop this webinar. So it was a collaborative effort, and part of the reason we did it as a collaboration is that we know that professional developers all around New England need to be grappling with the college and career readiness standards and being able to talk about them and talk about the shifts. And so it was an opportunity for all of us to think together and to talk through our understanding of how we would explain these aspects of the shifts of the standards. So this webinar, this first webinar, is on exploring the instructional shifts of focus and coherence. There'll be another webinar that we'll talk about at the end, which is going to be focused on the instructional shift of rigor. But before we get into that, let's meet our presenters today. Our primary webinar facilitator is Donna Curry, who probably most of you probably know. Here she's looking much more relaxed than she is today, but we hope she has a good time today as well. I'm in the middle. I'm hosting today and just kind of doing an MC role, playing an MC role. And on the right is Ben Bruno, our media specialist, who will help us with technology. And he's going to get back to us in just a second. We also have today as co-presenters Connie Rivera from Connecticut and Ronnie Tell from Massachusetts. Thanks to all of our presenters today who did a lot of hard work preparing. So Ben, could you do our tech prep for us?
Hi, yes. I'm Benjamin Bruno. I'll be helping out with the tech today. If you guys have any tech issues. So first off, if you have any tech issues, go ahead and send me a private chat. You can do that in the chat window. But let's just look at the interface. So you should be seeing just the slides right now and Connie and Ronnie's faces. That's where all the slides are going to be today. So you can see that. That's good. That's great. On the right side of your screen, there's a couple windows I want to draw your attention to. First, there's the participant window, and at the top of that list, you'll see your name followed by a list of everyone else who's on the call. You'll also see to the right of your name, there's a microphone button, and you'll see that it's likely red. That means you're muted, so I'm keeping everyone muted so we can hear the presenters okay today. So just remain muted, please. Below the participant window is a hand button where you, oh, hello? Hello? Hello?
Yeah.
Hello? Oh, I'm sorry.
Do you see Marilyn Moses has her hand raised?
Yes, I see Marilyn Moses has her hand raised. Sorry, there was just an audio interruption there for me. And yes, so you can raise and lower your virtual hand. So, but I recommend if you have a question that you actually use the chat box while things are going on. And the chat window is on the bottom right. It's right below where the raise your hand button is. And so what you can do is change the Send To menu drop-down, right where it says Send To. Right next to that, if you click that, you'll see that it says My Name by default, but you actually want to change that to Everyone, which is the top option. And when you send the chat, everyone will be able to see it. Lastly, we'll be doing a couple polls, and that'll come up on that right in that area, right below the chat window when we close the polls. They're just going to be simple multiple choice questions, and you'll just have to click them and hit send, and that comes up. We'll talk about that when that goes on. Lastly, if you get disconnected, you can reconnect just the same way that you did to join WebEx. If you get disconnected just on your audio, but not completely from WebEx, if you can still see the slides moving and chat, you can go to the top menu, and where it says audio, it's the 5th option from the left. Click audio conference, and then it will give you all the prompts to just reconnect your audio to your phone or computer. And that's it for me. Thanks very much. Andy?
Thanks, Ben. So, Marilyn, I don't know if you have your hand raised because you have a question. Perhaps you put that in the chat box. And if you want to lower your hand because you don't have a question, you can just click the raise hand button. It's a toggle, and it'll lower your hand. Okay, so moving right along, I just want to kind of mention a couple of things before we get started. One is that we're going to be talking today about the instructional shifts that are described in both what's called the Common Core standards and the College and Career Readiness standards. The Common Core standards were written for K through 12, and they are a large set of very detailed standards. A committee of experts, many from adult ed, met to winnow those down to a manageable number of standards and to focus them more specifically on what adults need for college and career readiness. And that subset of standards is the college and career readiness standards. So I just want to note that those are distinct things, but because Common Core is so much easier to say, a lot of times people will just refer to the Common Core, even in adult education conversations, just because it's easier to get out of your mouth. But those are two distinct things. And we're going to be focusing our webinars on the college and career readiness standards and the shifts related to those. Also, I want to note that even though we're talking about the shifts and not specific standards so much, we need to talk about the specific standards in order to illustrate the shifts, and therefore we're going to be referencing standards in the document. The link to the document was in the invitation message you got. And I just want to say that it would be maybe helpful for you to reference the document or have it handy or be somewhat familiar with what's in it, because we will be referencing the document. And if you don't have it today, you may want to take a look at it before the follow-up, the second part webinar. As I said, there are 2 webinars on the math instructional shifts. This first one is on the shifts of focus and coherence, and part 2 will be on rigor. And these 3 shifts are the big ideas that the standards are trying to emphasize in our instruction. And what I find very helpful about them is that if you understand these big ideas, you understand what the purpose of the standard, what the standards are trying to emphasize in our instruction. And sometimes if you don't understand the big ideas, you can get mired in the very specific leveled standards, and that can get cumbersome and it can be overwhelming. But if you really understand the big concepts that underlie what the Common Core and the College and Career Readiness standards are trying to do, it can really make the whole task much easier for you. So we are focusing on the instructional shifts. Also, as a region, different states are putting varied kinds of emphasis on the college and career readiness standards. They're also using different assessments, which are part of the conversation about the standards related to being able to assess them. But what's common across the states is the way we need to instruct, because all of the assessments are anchored in the college and career readiness standards. All of them connect to those standards. And so even if we're using different assessments in different states, all of us have to be paying attention to those standards. So it's of regional import. The other thing to remember is that the standards themselves are written as expectations for students. These are what students should be able to know and do. The instructional shifts are written for teachers. These are the main ideas, the emphasis that we think teachers and the standards are suggesting teachers need to pay more attention to in order to help students be college and career ready. So they are written for teachers. And finally, why pay attention to teachers? Why do they even matter to us? They're valuable for addressing the current gap between high school completion levels and college success. We've been hearing a lot about this gap between what students know at high school completion and what they need to know in order to succeed in college. And so the shifts in instruction are trying to help us bridge that gap. But as well as bridging that gap for college and career readiness, that improved instruction is going to help us promote more strategic and critical thinking that can be used for many things. It can be used for understanding issues that inform us as voters, or it can be used for being more critical consumers of healthcare and being stronger advocates for our families. So there is definitely a shift in the federal level attention toward college and career readiness, but many of us in the field are strongly committed to attending to the other purposes that adults have for learning and growing. And these shifts can help us with all of those things. Okay, so to get started, I am going to shift this over to Donna. I need to find your, hang on, Donna.
Capital D.
Capital D. I'm looking for you.
I took care of it. I took care of it, Andy.
Oh, okay. All right.
Okay, let's look at the objectives for today. And we have 3 key objectives. We're going to introduce you to the 3 college and career readiness standard shifts, explore how 2 of these shifts, the focus and coherence, influence the structure of the standards and the order that the standards should be taught. And then we'll consider how each of these 2 shifts plays out in an adult education classroom. One of the things I want to say, too, is that Connie and Ronnie and I are all pretty much hands-on trainers, and typically in webinars you wind up having information coming from the presenters out to you, and we're hoping to make this a little bit more interactive, and we will be asking you to participate in polls, as been mentioned, and we will be asking you questions, and we're hoping that you will definitely respond to those, because we'd like to make it a little bit more interactive so you're not just sitting there watching the snow come down. So what are those 3 shifts? And the 3 shifts are focus, coherence, and rigor. And as Andy said, the 3 shifts are about instruction, which is why we call them instructional shifts. However, the standards, the content standards themselves are written in such a way that they help us be able to shift our instruction. And we'll look at some examples today as we examine 2 of the shifts and how they play out in the standards. And since the focus is on shifts, not specific content, we'll be pulling examples and to try to illustrate what we're doing. And we acknowledge that sometimes some of the language that we use or some of the terminology will be uncomfortable for you, might even make you nervous, even though the ideas that we're pulling from are really at the lower levels. And we just want to acknowledge that up front, because you know, sometimes the tendency is to want to go ahead and really clarify exactly what the standard is all about, but the point is to focus on the shifts, not on the specific content. So we're hoping that our examples will help you understand the shifts, even though it won't help you necessarily understand the content of the standards. Some of you have seen this slide before, but I wanted to call out some of the pieces of this because we'll be referring to them throughout this presentation. Up at the top there where it has number and operation, base 10, these are now called domains, and Ronnie will talk a little bit about those domains shortly. We're used to talking about strands where we have 4 basic strands. We have number and operation sense, data and statistics, geometry and measurement, and algebra or algebraic thinking or pattern functions and relations. That content is really still the same, but it's reorganized a little bit, as Ronnie will share with you. But now you'll hear Ronnie and Connie and I talk about the domains rather than the strands. You'll see the standard statement, clusters of standards, and the level. The levels are levels in the college and career readiness standards. And as Andy mentioned already, that the college and career readiness are a subset, direct, without changing any of the language of the standard. So what was done was a little coding system that was put in place so that you'll notice, for example, after the first 1B there, you'll see a little code that says 2.nbt.1. And just know that the NBT stands for the domain. In this case, it's number and operation space 10. The 2, the first digit that you always see with any of the standards, tells you the grade level based on the Common Core. And then the 1 or the digit at the end tells you which of the standards it is in that set of standards in the original Common Core. So you'll see things shifted around, or you'll see a 1, 2, and then it jumps to a 4 or 6 or 8. It's because those standards were left out, and just the core of the core is what is now called the College and Career Readiness Standard. Levels A through D are really separated into a range of domains, and again, they'll sound very simple, similar to what we've looked at before, but they've changed a little. Level E is organized by conceptual categories, and this is really your high school math that we'll be looking at in a little bit. The standards are bundled into 5 grade level groups, and one of the things I just want to say here is that our national reporting system is based, of course, on 6 levels, not 5. That is an issue that OBE is well aware of and is taken into consideration right now. But the key message is teach to the standards, and you shouldn't have to worry then about the levels, because our students will get there. And there are 2 central parts to the standards. There's the standards for mathematical practice, which are really the overarching practices that our students should be able to develop as they're learning specific standards. And then there's the content, along with that content are the key shifts. So I want to make sure that that's highlighted, because the mathematical practice is really a critical point that nicely goes along with the shifts. Before I give it to turn it over to Ronnie to talk specifically about focus, I just want to ask if anybody has any specific questions about the College and Career Readiness Standards in general, either how they were developed, why they were developed, based on what Andy has said or I have said. Anybody have any quick questions? This is an easy question. Harder ones will come later. All right, I'm going to turn this over to Ronnie.
All right. So I'm trying to advance the slide, Ben.
Okay, while you're working on that, I noticed that there's a question from Gail. Will we be able to get a copy of this presentation sent to us? We can send you a PDF of the PowerPoint when we send you the link to the recording of the webinar. And it will also be on the NELRC website. How are you doing, Ronnie? Did you figure that out?
I think I have it. So I'll go from here. The first instructional shift that we're introducing today is focus. So what is that? Achieve the Core says that focus requires that we significantly narrow the scope of content in each grade and deepen how time and energy is spent on major topics in the classroom. So it's narrowing the scope of the content and looking at it more deeply. The writers of the Common Core, Phil Darrow, Bill McCollum, et cetera, they stated that the single most important flaw in United States math instruction is that the curriculum is a mile wide and an inch deep. This finding comes from the National Math Panel and from research that was done comparing the United States math curriculum to that of countries that are considered to be high performing in mathematics. So these standards took that into consideration and worked on the focus of the math content. The standards, then, are meant to be a blueprint for math instruction that is more focused and coherent. So the crosswalks and pacing guides that we create for our programs need to adhere to that focus and coherence of the standards. So what does this mean? Looking at this graphic, this is a great visual to show, you can see here on the left the domains, and on the right-hand side the levels from A to E. As you look at the domains and follow them across the levels, you can see that the domains are focused on a few topics at each level, and that there is a flow from level to level that provides coherence within each major topic. For example, if you look at the blue ones, they start at level A with numbers base 10, number base 10, number in operations, and they flow through fractions, the number system, all the way up to the real number system when you get to that high school level. So there's a really nice focus that flows. You can see that the domains, there are specific domains at each level. If you look down farther at the orange, bluish, orange, brownish category, those are the algebraic reasoning domains, and those have the same sort of focus within each level and across the levels. This will allow us to build in our students what they need to really concentrate on functions and algebra when they get to the high school level. So, looking a little more closely, you can see that there's a clear focus from the earliest levels on instruction that prepares students to be ready for algebra. Each domain, looking at the yellow side there, the yellow-orange, each domain has a narrow and deep focus. Fractions, base 10, algebraic thinking. And as you move through the levels into the middle level of adult education, it moves more towards expressions and equations, a look at the entire number system, and then there's a fluid movement from there into looking at formal algebra at the high school level. Later in this presentation, Connie's going to be illustrating an example of this movement, and hopefully that will help to deepen your understanding of focus and coherence. So what does focus mean for instruction? Use the power of the eraser to move away from the mile-wide, inch-deep curriculum. Many textbook lessons need to be eliminated in an effort to provide our students with an understanding of why, as opposed to remembering how, as we prepare them to be college and career ready. Lessons will need to be identified or created as we narrow and deepen the focus on the major topics in the classroom. So a statement that we often hear is, I don't have time to deepen the content. Our students are with us for only a short period of time. So what we'd like you to do here is take a minute and think about this statement, and then in the chat box, respond to it. I don't have time to deepen the content. Our students are with us for only a short period of time. So take a minute and please respond in the chat box.
Okay, Kristen says better to strengthen. Oh, I just jumped a few skills rather than give a bunch of weak skills. Gail says in the short time that they are there, deepen whatever content you're presenting in that time. We need to focus that their time with us is worthwhile.
We hope that as we go through this webinar that you see ways in which this can be done, that we provide a response to those statements. So Donna, I'm going to pass this to you.
Okay, let's just hear from a few more comments that are coming in. Erica says it can be quite difficult because I teach adults and our enrollment is ongoing, so students are coming and going, and the dynamic is constantly shifting. Christina, this means that we have to be all the more thoughtful in our lesson planning. Okay. Bridget, I'm finding it really deepens their understanding a lot faster this way. I'm going to jump down a little because it's going to be too fast for me. Robin, I understand that, but it is my philosophy that it is better to focus on quality and not quantity. We need to fill gaps that are there and not make larger ones by focusing on too much. Okay. Anne says, I tend to wrap in-depth as I'm teaching easier concepts through very quick and focused questions that tie in previously presented material. I feel like I'm spiraling the info constantly. Not everyone will get it if they aren't ready, but it works for most students.
And Jennifer says it requires a conversation with students, that the process necessitates a longer commitment.
Okay. And Candy says, go ahead. Candy says, does this comment come from a fear on the part of our instructors that time is limited and students from varying backgrounds have holes across the curriculum? For example, higher level students who still struggle with place value.
And Jill says, I think it's sometimes harder to stay on one topic and make sure it is presented in a myriad of ways, and students have a number of opportunities to express what they know and have learned.
Okay, go ahead, Donna.
I lost where I was. Oh, Bonnie, we can tap into adult learners' knowledge cache and their abilities and purpose for learning to make the most of the time.
Okay, I think you can move on.
Okay. I need to be in control. Or, Ben, do you want to put up the poll?
Sure. Let me just move this slide. I'm just going to take control for a second.
Did I not pass the?
Oh, it's fine. Donna has two computers going, so no sweat. Hold on a second. I'm about to poll. Just need to bring up that window.
I'm an overachiever. All right. What we'd like to do now is just ask you to respond to two questions here. And first of all, I want to say that we're not going to see who answered how, so don't worry about making sure you have the right answer. And we also want you to answer as honestly as possible. And the two questions are, which of the following do you teach your students in the first list? And then which of the following do you directly or explicitly teach your students? So we're really wanting you to list which ones do you actually sit and teach to your students. So go ahead, answer, and we'll see how you do.
And when you've finished filling it out, make sure you click the submit button at the bottom of the poll. We've got about 15 people still filling it out, so I'm just going to wait for them to finish.
People are trying to probably figure out what some of these are.
Yeah. Okay, I'm going to be closing it in just a few seconds. Okay, here we go. So you should be able to see those poll results in the bottom of your, below the participant window where you took the poll. And you can resize those columns if you need to see them a little bit better.
Great. And I see some no answers. I'm assuming that those are individuals who don't teach or don't teach any of these things. It looks like up at the top there are a lot of PEMDAS, whatever that means, and cross product. And then in the second clump, distributive property, definitely, commutative property, associative property. Those three look like they're the biggest bars there, but associative property, multiplicative identity. It's great to see so many responses. So, and actually, I think probably all of us at some point in time in our teaching have either taught or learned some of these various strategies. Connie and Ronnie and I have been reading and listening to the authors of the Common Core Standards and therefore the College and Career Readiness. As they've described their thinking behind the three shifts. And one of the points that they've often articulated is that we as teachers sometimes add more to the curriculum than is really necessary. And Ronnie mentioned that we have to eliminate lessons. And it's like you look at the standards and you say, how can I eliminate lessons? And there's so much to teach and I have to teach all this stuff. And they suggest narrowing the focus and teaching big ideas such as those listed under the second clump, those under the second question there. And if we talk to bigger ideas, maybe we wouldn't have to deal with the isolated procedures, mnemonics and tricks, which is what is a lot of the first list. So we wanted to illustrate that, and so here's an attempt. This is the first time I'm trying this to see if it works, to really illustrate how teaching to big ideas can really help lessen the amount that we're teaching. So let's see how this works. All right. Here's our typical problem of a division problem. And here we have the individual who says, okay, let's see, 9 to 5 goes into 9, 1 time, bring down the 1 times 5 is 5, bring down the 4, and you have to bring down the 2, and you know that procedure. And probably most everyone on this webinar has taught and learned the division algorithm this way. Some of us figured out why it worked, a few of us anyway. Many of the rest of us memorized the procedure because we were good at memorizing and became comfortable with the notion that math is just a bunch of isolated skills to memorize. So here's one more thing to memorize. Others of us who couldn't remember the steps were sometimes given mnemonics to help us. For example, in this case, I might want to remember the mnemonic dad, mom, sister, brother, rover, divide, multiply, subtract, bring down, remainder, which are the steps of long division. Of course, one of my problems was my dog's name was Lassie, and I never could figure out what to do after I subtracted because there wasn't an L there. But what if we taught this long division algorithm differently and didn't teach the algorithm? So here's this individual thinking, she has an understanding of the big idea of what division is. And there are different meanings of division, and one of those is the idea that you can take equal size groups. It doesn't matter how many clumps of equal size, in this case, how many 5s are you pulling out, that you take at a time, as long as you get them all. I could have taken 2 sets of 5 at a time and subtracted 10, 10, 10, 10, or I could have done 5 at a time. 5 times 10 is 50, and taking a clump out. This person took a clump of 9 5s out, and she subtracted 45 and still had 47 left, and she said, oh, I can take another clump of 9 out. And so I have 2 clumps of 9, or a total of 18, and a remainder of 2. She got the right answer, but she did it because she understood the concept of what division is. So as long as she understands why she's doing it and the conceptual understanding of what division is, it shouldn't matter how she goes about the process. And by the way, there's just one thing I want to say about this that's always bothered me. And we know that 9 there in the dividend is really not 9, it's really 90. So if you think about it, when you say, how many 5s are in 90? Well, I know my 5 facts pretty well, and I know 10 5s are 50 and 20 5s are 100. So there's almost 20 5s in 92. There isn't 1, and there isn't 10. So sometimes the procedure in this algorithm always works, but sometimes we lose the meaning because we're so struck with this is this technique, and so it always works, but it doesn't always make sense. So another reason that our students may not have a full understanding of what this procedure is all about. All right, let's look at one more example to talk about looking at discrete skills that we think we have to teach versus looking at the big idea. Borrowing. It's a real challenge for our students, and it's especially a challenge, we know, when we start to add zeros up there in the minuend or up in the top number. And so this fellow is trying to follow the process that he's been taught, the same one that you and I have been taught, and he may get it or he may not. But is there another way that we could teach? This person has some number sense, and he's thinking, if I think about those properties, and all of you say that you're teaching these properties, if I use some of those, maybe I won't have to deal with that subtraction algorithm. Maybe I won't have to borrow. So it says I actually have several options, but the 2 most obvious are either to change the first number so I don't have to borrow, or I can change the second number, and then I also won't have to borrow. I could make 94 into 98, and that would mean adding 4 to 94, or I could add 2 to 38 and make it 40. Let's see what happens and why that works. What allows me to play around with numbers are properties. In this case, you could have used the additive inverse, and in the first example on the left, if you add 4 and subtract 4, you still have 0. Nothing has changed. Plus 4 minus 4 is 0. Plus 2 and minus 2 on the right-hand side is still 0. The more that you can play with numbers, that you can deconstruct, reconstruct numbers, it's actually to your advantage because you're building number sense. And actually, this is also very good for mentally being able to calculate. If I can play with numbers, move them around a little bit, then I don't have to worry about borrowing. I can simply readjust and be able to solve things in my head. The other thing is he could have also used a number line and added up from 38 to 40, which is 2. You can hold that in your head because we're going to do this mentally. And then count up from 40, 50, 60, 70, 80, 90. There's another 50, so now we're up to 52. And now we have to get to 94, which is the original number. So we add 4 more and we come up with 56. Another strategy. And by the way, using a number line and adding up instead of subtracting and borrowing illustrates the direct relationship between addition and subtraction, which is a big idea. And maybe people could count back change if they were taught that you could count up or add up from your subtrahend to the minuend, or from what you're taking away to your original amount. So there are different strategies that you can use without learning this algorithm, but using instead properties of numbers and an understanding of the relationship between addition and subtraction. So before we move on to coherence, we try to give a couple examples of what it might look like to focus our instruction rather than a bunch of discrete skills looking at some big ideas. Are there any questions or thoughts about focus? Did this help at all? Anybody?
Well, Kristen, can you hear me?
Yep.
Kristen says, I get the impression that there's a lot of undoing of bad habits, both on the part of teachers as well as students. And Jennifer says, I've always taught many strategies like this, but the irony is that students know on the high set test that they're able to use the calculator throughout the test, and so they see less importance on having to learn how to do it in their heads or on paper. It becomes about the test.
Mm-hmm. The comment about having to change some habits with teachers and students, again, you know, the whole idea behind the shifts and the way that they're written in the standards really helps us to make those changes. And Connie is going to really be able to illustrate that for you, because I think the writers of those standards realize that things have to change for us as teachers, and then help students make the changes as well.
And Anne has kind of reinforced what you're saying. She says, I'd love to learn more strategies like this to reinforce why we do what we do.
Mm-hmm. Mm-hmm. Great. All right. As we move on to an introduction to coherence by Connie, we want you to, again, think about your own classroom. In this case, we're going to have you do another poll, then. And this poll, in this poll, you're only going to be able to give us one answer for each question. And the questions are related to what you teach most often. And the first question is, which of the following do you most often spend, do you spend the most time on? And then which of the following do you most often have to reteach? It could be one and the same answer. It could be, do you do a lot of teaching of something and you wind up having to reteach it a lot? Or it could be that you do a really great job of teaching something and you never have to reteach it. So for this poll, just to get us thinking about what you teach and how you have to reteach it, one answer for each of those. Go for it.
Just waiting on a few folks to finish up, so I'll close this in a few seconds.
Donna, can you check your chat box? I sent you a message.
And here are the results.
Donna, are you there?
Yeah, Connie?
Yes.
Yeah.
Do I have the, I don't have the screen yet. Now I do. Sorry guys, we're practicing the switching still, I guess. So next. So I noticed in the poll that fractions was the #1 thing that we need to spend the most time reteaching, and it's also where we spent most of our time teaching. Some other highlights, we spent a lot of time reteaching percents as well, but fractions was the #1 thing that we had to reteach. So why do we think that we have to keep reteaching things like fractions and percents? You can answer in the chat box. We're wondering what the reason behind having to spend the reteaching time on these topics is. It's a harder question. I see if you don't lose it, you lose it, and that's the skill of fractions, because they didn't understand it the first time from Susan. Wasn't taught in depth the first time. They don't practice in daily life.
They don't get it.
And context. Fractions equals fear.
They've never learned the rationale behind the process to begin with.
And Aaron says students are learning the process, how to do something, but they don't know why, or the broader mathematical reasoning, and so it is not learned.
It's too abstract.
Students are not practicing outside of the classroom.
The rules and vocabulary change for fractions, and sometimes elementary and middle school math isn't taught by teachers who love math. The relevance to their own life.
There are so many concepts with fractions in and of itself, let alone that fractions lead to percents and decimals. All right, so Connie, you might enlighten us a little bit with fractions as well as coherence.
Okay. Oh, wrong click. So we need to spend a lot of time teaching those topics because of our current methods of instruction, and our second shift, coherence, can help with that. So typical high school equivalency exam prep books are organized as separate standalone units, and you'll find something about number sense at the beginning of the book, and at the back of the book you'll find algebra and geometry at the end. And coherence looks at the units very differently. So for example, if you're teaching multiplication, you're teaching area at the same time. It's not a separate unit. Here's a description of coherence from Achieve the Core. Coherence is about making math make sense. Mathematics is not a list of disconnected tricks or mnemonics. It is an elegant subject in which powerful knowledge results from reasoning with a small number of principles, such as place value and properties of operations. The standards define progressions of learning that leverage these principles as they build knowledge over the grades. Later in this presentation, we'll take a look at an example of a progression of learning and of this learning that leverages these principles, which essentially is coherence. And we'll look at a level B example. So another question for you. How does this description about what mathematics is corroborate or contradict your beliefs about teaching? How does it fit when you read, mathematics is not a list of disconnected tricks or mnemonics. It is an elegant subject in which powerful knowledge results from reasoning with a small number of principles? I'm going to second what Anne said. Frankly, I didn't understand most of the math rules until I started teaching them, even though I thought I was a math major for a while. I was taught during the time that it was about memorizing procedures, and so I was lacking in the conceptual understanding. We'll take a look at some examples that will help us with that. It makes math sound more fluid and less about separated skills. From Candy. Just gonna wait one more half a minute there for other thoughts. It merges understanding and application. It explains why students are good in math, who are good in math, also tend to do well in other subject areas. Christina says, I truly think it is a language, and if students can understand the language, they can understand so many principles. I like that focus on the principles. Students, oh, I just lost it. Students won't trust their own reasoning until they have a basis of understanding.
Math ties the universe together, Jason. Donna Chambers says, if the approach to teaching math has to do more with understanding the underlying concepts, the student's more likely to grasp the basics. Okay, Judy, it's the connection about life around us. Math is everywhere. See it, draw it, connect it. Bonnie says, I lucked out and had new math in high school. It was all about the reasoning and elegance, learning how numbers behave. Oh, I like that, behave.
So, So what does coherence mean for our instruction? Coherence implies that our instruction should connect the learning across the levels so that students can build new understanding onto foundations built with previous skills. So we need to make sure that we build a foundation and not just jump in and teach at the top of those skills. Just because you're getting ready for a high school equivalency exam doesn't mean that we should start with the high school standards. We should provide links from one level to the next in order for students to progress mathematically. And we should understand that each new standard is not a new event, but is an extension of previous learning. So not a new event says to me that everything is connected to the next concept. And we'll take a look at an example staircase in a little bit that'll help illustrate that. So let's explore coherence with an example of a group of standards to make this a little bit more concrete. Take a look at these 5 standards. They're all from level C, and you can tell that they're from different grades by the code at the end. What strikes you about this sampling of standards? And we're focusing on not necessarily the content, but we're talking about the shift and the shift of coherence through this. Math is a progressive subject. So what strikes you about this grouping of standards? Jennifer says extension. I see that word in these. I see extend understanding, extend previous understanding. That's repeated throughout. The progression of verbs as the grades go higher, extend, build, and apply, from Christina. Rosa says, in order to be able to do fractions, you have to have basic math to continue. And Erin says, each standard is asking you to extend previous knowledge into new concepts. Early steps build the next, from Bonnie. And Jason says, a development of usage. To build on what Jason said, I also noticed that these all talk about fractions, but NF is only on some of these. There's also NS for the number system. So they're in different domains. So let's look even more closely and focus on this one standard that was on the list. Apply and extend previous understanding of multiplication and division to multiply and divide fractions. So what understandings from multiplication division from multiplication with whole numbers can we apply to multiplication of fractions? So Anne is saying that students need to know their basic math facts. They need to know how to multiply with basic facts before they can apply it to multiplication with fractions. Factors represent either the number of groups or how much is in each group. So conceptual understanding there. It's like an entire pizza that's divided into a certain number. So giving some context. Carrie says the new number and the new numerator and denominator will either be the same or larger. Bridget says they get smaller because you're multiplying by a number less than 1. 1 keeps it the same size. Let me add on to that question. Do the commutative and associative properties work for fractions? I'm hearing yes from Bridget. And how about the distributive property? More yeses. How about the multiplicative identity property? How can that help? Shirley says yes to all the properties. So that's another connection that we can make. These standards at level C are already using variables. And from a student's perspective, those are those scary letters I remember seeing around the time that I left school. And I recognize that as the math I couldn't do. So we must introduce the distributive property early on so that students can build onto their understanding of that property, providing a coherent link progressing from one level to the next rather than connecting the distributive property only to math with letters. How can we teach this while students are learning their basic facts? This is more of a rhetorical question because we're going to show you an example. It's something to be keeping in mind. We'll look at the area model of multiplication and its connection to the distributive property in a minute, but first we have a poll to get you thinking about what you teach, when you teach or don't teach properties explicitly. So the poll is going to be coming up in a minute, but the questions are going to be these. When do you typically introduce the associative property? When do you typically introduce the inverse property of addition? And when do you typically introduce the distributive property? And you can also reflect on that question. Oh, can't go back. The question that was up previously, focusing on the expressions and equations distributive property. Yeah, that was it. So nobody can see our poll responses, so go ahead and speak honestly. We just get a summary of everybody's scores.
Just a few more people finishing up, so we'll go ahead and close this in a few seconds. Okay, here are the results.
All right. I'm seeing heavyweight at answers of when I'm working on basic number facts with all three of those are the heaviest in all three of the questions. That's a good sign. Oh, disappeared when I got the, okay. Gonna go again.
I'm sorry, can you not see the, can you see the poll?
It disappeared when you passed the ball to me, so it's back. I got it back up again.
Oh, you got it back up. Okay.
I do. So when I introduced algebraic expressions was another common answer that we're waiting to teach properties at that point. So I'm just going to remind you of the quote that we had at the beginning of the coherence section, that mathematics is an elegant subject in which powerful knowledge results from reasoning with a small number of principles, such as properties of operations. So properties need to be introduced with basic facts and reviewed with every context, fractions, area formula, algebra, and we can see that we're still making that instructional shift, and some of us still need to be thinking about how to make that shift, and it's an ongoing process. Here's the staircase that I mentioned earlier. Take a look at this progression that makes operations and algebraic thinking coherent across the levels. These are standards from grade 1 to 3 to 6 to 7, which for us is level A to B to C to D. And notice that all of them say, apply properties of operations. There's more than one way to set up a grouping like this, but this is one example. And now we're going to take a look at the area model of multiplication. This model of 6 times 18 shows me that 6 rows of 10 and 18 is the same as 6 rows of 10 added to 6 rows of 8. It helps me visualize the distributive property long before we get to using variables, and it also can help me break down multiplication facts that I don't know. Students can use this with single digits instead of anything with 10. The area model can help us see why procedures such as 2-digit by 2-digit multiplication work. You can see the place value in an example like this. So if I'm looking on the left-hand side, 2 sets of 10 blues gives me 20, and then add 6 yellows to it. That's 26 for one dimension. Another thing that I can see by using the area model is I can see that that green section there, now that's where the 6 and the 8 intersect, and so that area has 48 blocks. Oh, well, 8 times 6 is 48, so now I see why that's represented there. But area models can be used for other things as well. So let's take a look at an example using fractions. So if I need to multiply half times 2/3, I can have a whole, and then cut it in half in one direction and in 2/3 the other direction. But I'd like to take a look at this stacked. So if I start off with my 2/3, because I prefer to say a half of 2/3, I can understand the context there, that instead of saying times, which feels a little bit more empty to me, if I say of, it helps me picture the situation. So if I've got 2/3 and I take half of it by just cutting it in half the other direction, I can shade half blue to show that I have 1/2. And then if I've done this with my students and I'm using highlighters, then I can see that yellow and blue make green. So when those overlap, I've got the green section that gives me my answer, 2/6. This helps me understand why when I multiplied, the pieces got smaller. And now I can see that multiplication doesn't always make things bigger. Another area model. If I'm going to be in algebra and I want to multiply the binomial x plus 2 by the binomial x plus 5, it doesn't have to be all that different than what I learned about area when I learned to multiply. So I can imagine that this is x and any distance representation of it, and this is 2, whatever my unit is, and the other dimension going the other direction. Here's x, it's the same as my other x, so I'm going to end up with a square. And here's 5. I'm adding that to the x. And since this is area, let's define the area. And now I can see what I've got laid out, but color makes everything better, so let's look at it this way. So now that I've got my dimensions laid out, my spaces defined, I can begin to multiply. So let's start with blue, x plus x. Now I can do x plus 2, 5 plus x, I'm saying plus, excuse me, multiplied by. These are dimensions that I'm multiplying. Adding will come later. And then 5 times 2 is 10. So everything is multiplied in this screen. So these are all the pieces that I would have if I had applied the FOIL method. That was the first, outer, inner, last procedure that was asked about in the poll at the beginning. I can see that this is all the pieces that I would have. So I may have written it out and done the adding the areas together. And then when I simplify, I've got my answer. And as a visual learner, this model gives meaning to an otherwise robotic procedure. If I'm just saying first, outer, inner, last, I don't know what that means. I'm just following a procedure. And that procedure doesn't work for anything else. You can only use it to multiply binomials. So this is the benefit of coherence. I'm connecting my knowledge of related aspects of math using area models, and I'm skipping past learning those discrete skills that don't help me understand any other areas of math. So now if I have heard of the term FOIL, I can picture why it works. Now I get it. So to review the shifts that we've been over, focus requires that we significantly narrow the scope of content at each level and deepen how time and energy is spent on major topics in the classroom. Coherence is about making math make sense. Mathematics is not a list of disconnected tricks or mnemonics. It is an elegant subject with a small number of principles such as place value and properties of operations. So here's something for us to reflect on and share together. What do coherence and focus in adult education classroom mean to you, and how might these shifts influence what and how you teach? As we've gone through, the questions have gotten harder, and so has the pause before the chat answers. How are these shifts influencing what and how you teach?
I also wonder if maybe people want to post what their ongoing questions are, the questions that remain, because this was just a taste of this topic, and I think people may still have questions.
So Bridget says, it has really brought me back to the why of the operations. Rosa said, I'd have to study some more to get a technique down and find the best way to work with my students. Yes, I'm constantly rethinking, why am I teaching it this way? Jennifer says, we need to remember that this coherence and focus standards build from K to 12. In the adult education classroom, we're dealing with students who do not have the background. It requires more of all of us, but I will stress again that students need to be told emphatically that these new standards will be a slower process for them. Even though we are teaching adults who are in that entire range, we can still build skills like, maybe this is too far back to go, but I'm going to just put up the staircase again. Oop, I got carried away. Narrowing the scope of the content when the concepts apply at many levels brings coherence. Laura says, we can afford to spend the time developing strong understanding if the skills transfer to a continuation of learning. And Ann says, I want my students to finally understand why numbers work the way they do, why numbers work the way they do, so they don't have to do it over again. I want what I teach to address the needs of their goals, high-set college or career. I want them to have the confidence they've never experienced with math and realize that they can overcome their fears. Beautifully written.
And Bonnie says, narrowing the focus of the content when the concepts apply to many levels brings coherence. Connie, you going to read one?
Yeah, it's jumping, so I was trying to find my spot again. I'm wondering how to design our math program so that we can help make more coherence for our students. And Erin says, go ahead.
Narrowing the scope will free up more time to deepen student understanding. Teaching with coherence will require more creativity and creation of new lessons, but I think it's worth it. Bridget says, I keep hearing my students say that they never understood the concept and now do. And Jason says, the quicker the students get it, the quicker that they can move through our program. The more coherent math is, then students will be able to have skills that will last out of our classroom. And Bonnie, we could tap into peer learning, letting students who get it help others get there too.
Great, great. All right, this is basically sort of into this presentation, and we're going to turn it back over to Andy if you have no further questions. Andy?
Okay. Well, this is really just to wrap it up. I want to big thank you to our presenters, Donna, Ronnie, and Connie, for doing a really good job at summarizing what these shifts are and illustrating what they really mean in practice. I'm not a math person, but I was kind of really excited about the shift to the why, to really understanding the why underneath the technique. So I was jazzed by that. And to all of you for being in this conversation. There were lots of invitations for you to chime in, and many of you had really great things to contribute. So we really needed you. You could have all just listened to the recording and not spent your afternoon this way, but we're glad you were here to contribute this way because it really is a way to build our collective understanding of what these shifts mean. Okay, give me the last slide, and then we will wrap it. I don't know who has control, but one more click over. Sure. Okay, so there are just a couple of reminders that the next webinar about the third instructional shift, which is rigor, is on February 25th at 3:30. You don't have to re-register for that. You're registered already, and you'll get reminders. You will also, as Ben said, get a link to the recording of this webinar and the PDF of the PowerPoint, and everything will be archived at nelrc.org. And when you get off the webinar, you're going to be emailed a very short evaluation survey that would help us understand what parts and what elements of this webinar were helpful for you and what maybe not so much, and that'll help us create a better webinar for you in a couple of weeks. So if you wouldn't mind filling that out, that would be very appreciated. That concludes our webinar. I hope you have a lovely afternoon. Go get a chance to play in the snow or shovel if you're not getting a chance to play. And I hope to see you in a couple of weeks. Thank you. Have a good afternoon.
Thank you, everyone.
Thank you.